Hi everyone, this video is on exercise 9J question 7. So this is a typical modeling question with differential equations. And in questions like this, where it's usually about a container, a very good approach can be use a very simple diagram. So in this case, let's say this is the container. And always there are two different things that you should be looking at. One is the inflow of the liquid, so inflow to the container, and the other one is the outflow of the liquid. So the objective is basically finding each of these. So we need to identify which of the given information is about the inflow and which one is about the outflow, and then therefore we can form the equation. Because remember, the equation is all about the rate of change of the volume, right? So we always, in questions like this, we can start with dV/dt, because again it's about the rate of change of volume. So that's one side of the equation. Now the other side of the equation is the part that can sometimes be challenging to find, but in this case it's actually straightforward, because at first it says liquid is pouring. So this is about the inflow at a constant rate of 30 meters cubed per second. So this simply means that every second 30 centimeters cubed is basically poured into the container. So we just have 30 here. So 30. That's the first thing. And the reason we don't need to include anything else is because this is just a rate, right? So there is no need for any, constant or other variable that is here, because it's just a rate. It's the rate. And then it says that time t seconds, liquid is leaking from the container at a rate of, so we are given another rate, but this one is slightly maybe more interesting. So this time for the outflow, what's going on is that the outflow is actually 2/15 of V. So what this means is that every second 2/15 of the um, volume is basically leaking from the container. So the reason that it's negative is because this is the outflow. That's the first reason that it's negative. And also the second thing is about just the interesting part, because as you can see for the outflow, they didn't give us, just a constant number that says, oh yeah, every second there is this constant amount of liquid that is flowing out. It's not like that for outflow in this question. So it's proportional to the volume. So the more liquid you have, the more the outflow is going to be. Okay, now this is basically the differential equation. We just need to show that this is the case, and we just need to basically multiply everything by 15 just to get to that form basically. So we can multiply everything by 15 to get 15 dV/dt is equal to 450 minus 2b. So as you can see, we are very close. We just need to multiply everything by -1. So it's going to be negative 15 dV/dt is equal to minus 450 plus 2e. And this is exactly what the question is looking for. Okay, that's it for this video, and thank you for watching.